Hi, everyone. Like Rucha said, I'm Osber Bassani. I'm one of the authors on the original GLADE paper on synthesizing program input grammars. And today I'd like to just share a brief response on our kind of views on the replication study that was just presented. And before I begin, I'd first like to thank the conference organizers for giving us the chance to provide this response, and I'd also like to thank the authors of the replication for taking all the time to actually go and replicate our work. So just to kind of set the stage, I want to just, and make sure we're all on the same page, I want to go over the ACM definitions of what it means to be reproducible or replicable. And basically this depends on who is doing the study and what the experimental setup is. So a repeatable result is one that's by the original team using the same experimental setup. Reproducible results are ones that are by a different team, but still the same experimental setup, and this is the usual standard for publication. And finally, replicable results are ones by a different team and a different experimental setup. And so just to kind of emphasize, the current study is not a reproducibility study. In fact, the GLADE artifacts are publicly available, and the authors actually chose and you can use the publicly available artifacts to reproduce the original results in our paper. The authors specifically chose not to reproduce the results using these artifacts and focused on kind of building their own new implementation. Another thing is it's also not a complete replication study. So the authors really focused on replicating just one result in the paper. And in our view, at least, they chose not to really replicate the main results of the GLADE paper. So what do I mean by this? Well, in our paper, we had two main experiments. The first one was a comparison of GLADE to state-of-the-art synthesis algorithms at the time, namely L-star and RPNI. And the goal of this experiment was just to show that we would outperform these existing algorithms on some toy synthetic grammars. And the second experiment, which we really saw as the main experiment, was to use GLADE to actually fuzz test some real programs. So the authors really only focused on the first experiment, and more so they only focused on replicating the results of GLADE, not the results of the baselines. And their main result is showing that the F1 scores obtained are lower than those reported in our paper. And this is not that surprising to me. You have a new, basically a different implementation, an implementation completely from scratch based only on the paper without examining the publicly available implementation. And they also were using a very different experimental setup. So different ways of generating seed inputs, different ways of basically generating samples to evaluate precision and recall. And if you look at the ACM definition of replication, you expect, it's actually expected to have some variation in the results. From our perspective, the real question isn't do the numbers come out exactly the same, it's do the conclusions of the experiments in the paper come out the same. And our main conclusion was that GLADE significantly outperforms the state-of-the-art at the time, which was L-star and RPNI. And in fact, if you look at their numbers, they're actually consistent with this conclusion. We can't be sure because they didn't replicate these baselines, but they actually look pretty good. So just to illustrate what I mean, these are the numbers from our paper. So as you can see, GLADE is in black and it significantly outperforms the two baselines. And if you plot the numbers from the replication study in red, it still significantly outperforms the baseline. So I would actually be very happy to have posted these results in our original paper, if that's what we came out with. And yeah, there are various explanations for differences. It isn't different implementation and a different experimental setup that can lead to these differences that are reported. So beyond the partial replication, the authors also studied a number of new directions which were out of scope of our original paper. For instance, they point out that it fails to learn the palindrome language. So this is a fairly simple context-free language, but it's not really a program input grammar. So it's not like the input language for any typical program. And we actually made some specific design choices that rule out languages like this to focus on program input grammars. Another thing they point out is that it learns large grammars. And this is something that, partly we just didn't really try to optimize this because it worked for our setting. We had grammars that were good for fuzzing, and we could also do parsing. And But we think these are potentially very interesting directions for future work. So just to kind of conclude very briefly, the main finding in our paper was that GLADE was the first tool to achieve non-trivial performance at synthesizing program input grammars in the black box setting. These results, we stand by them, and they can be reproduced using the publicly available artifacts. The replication study doesn't try to replicate this result, but it actually, we think it supports this result pretty well. And they also point out some interesting opportunities for improvements and future work. And I'd just like to thank the organizers one more time for giving us the chance to respond, and I'll be happy to take any questions.
So thanks for taking the time to make this response. What I'm trying to think about as part of this is, what should I take away, what new should I learn about GLADE from having heard the replication study and your response? Like, is it kind of more sensitive to input, or what do you think is kind of underlying going on here?
Yeah, that's a really good question. So I think, yeah, definitely there are different settings under which you will get different performance profiles. That's something that we probably should have explored a little more in the paper, but as I said, our goal was to really focus on comparing the baselines. We didn't do a careful kind of sensitivity analysis to the way the inputs were generated. Yeah, and there are a couple other takeaways. So it does learn large grammars. That's something I think we reported in our paper, but they really highlighted. And I do think interpretability is a big problem if you want to use these in applications other than fuzzing, or basically when a human needs to look at it, then that becomes important. But if you just want to use it in a fuzzer, then I think it's actually fine.
Hi, thank you, by the way, for preparing this. This is great. Something that hasn't come up today in either of the talks really is one of the main points from the replication study, which is that the grammars used for, say, XML and grep were possibly too permissive. And I guess, could you speak to that? Do we think that's actually a big issue? Is it a little problem, a big problem? What's up?
Yeah, so yeah, this was, for those of you who don't know, this was a claim in the paper that some of the grammars that we used were too permissive. So this was really focused on the toy synthetic grammars from our first experiment. So we had a second part that was focused on actual programs. So we kind of wrote these grammars by hand, and there might have been, for grep, they didn't actually say, or at least I don't remember if they said exactly what the issues were with the grammar. For XML, it was actually, again, I don't know exactly what the differences are, but we were actually using an XML validator to check those inputs. I think it might have been using an older version of XML, so that might have accounted for some of the differences. But yeah, I mean, these things are generally pretty complicated, so there are going to be discrepancies and things just because real world is complicated. Thank you.
With that, we need to end this session. Thank you all for your enthusiastic participation.